Hi there, my name is Tawfiq Umar Uthman, math teacher. In our lesson for today, I'll try to explain how we can use the second derivative to find the local maximum and local minimum. Please, there is a link down below at the description for exercise. Download it and use it carefully. And do not forget to subscribe the page and write your comment if you have any, and push the like button. Thank you for that. Let us start our lesson. Maximum and minimum finding using the second derivative. If x is equal c is a critical value, then it is a local maximum if the second derivative, if double prime of c is less than 0. That means if it is negative when x is equal to c. And if it is a local minimum if the second derivative is positive, that means bigger than 0 at x equal to c. As you can see here, at the maximum value, the value of the second derivative is negative, and at the minimum value, the second derivative is positive. The second derivative is positive. Step to find the local maximum and local minimum and inflection point using the second derivative. The first step, find the first derivative and the second derivative. After that, find the critical value by solving the equation f prime of x is equal to 0. That means when you make the first derivative equal to 0 and find the value of x. Third step, replace the critical value instead of x in the second derivative f double prime. And if the second derivative is bigger than 0, that means its value is positive, then the critical point is minimum point. And if the second derivative is less than 0, that means it is negative, then the critical value is a maximum value. But if it was 0, then this is the test B failed, and we can use the first derivative to find if it is a local maximum or a local minimum. But almost times this kind of point is an inflection point. Hint, be careful, I will give you a table which is very important to know the relation between f and f prime and f double prime. We know the function f of x, it be increasing or decreasing, and it has a critical point, and this critical point maybe is converted to the maximum or to the minimum, local minimum and local maximum, or it become inflection points, or the function be concave at an interval and be convex and in another intervals. And now f prime of x, what is the value of f prime of x, or the first derivative, when the function is increasing? When the function is increasing, the value of f prime of x is positive, and when it is decreasing, the value of f prime of x is negative. That means if the first derivative is positive, then the function fx is increasing, and if the first derivative is negative, then the function f of x is decreasing. At the critical point, we know that the value of the first derivative is 0 or it is not exist. That means at the maximum or the minimum, local maximum and local minimum, the f prime of x is 0 or not exist. To find the inflection of point, we must have the second derivative. This is the second derivative. In the inflection point, or when x is f prime of x is positive, and if the critical point has a maximum, then the value of double prime of x is negative. At the minimum, the value of f double prime is positive. At the inflection point, the value of double prime of x is 0 or not exist. Because there it has a 0 or not exist, that means the first derivative almost have a maximum or the minimum, local maximum or the local minimum. And when f of x is concave, then the second derivative is positive. Because the second derivative is positive, that means the first derivative, it must be increasing. And when f of x is convex, then the second derivative is negative. That means the first derivative is decreasing. This is very important table. When the function is increasing, the first derivative is positive. When it is decreasing, the first derivative is negative. When it has a critical value or maximum or the minimum, local maximum, local minimum, then the value of f prime is 0 or not exist. And when it has a maximum, the value of f double prime is negative. And when it has a minimum, then the value of f double prime is positive. An inflection point, the second derivative is 0 or not exist, and the first derivative maybe have a maximum or the minimum. When the function fx is concave, then the second derivative is positive and the first derivative must be increasing. And when f of x is convex, then the second derivative is negative and the first derivative must be decreasing. Example: find the local extrema for fx is equal minus 3x to the power 5 plus 5x to the power 3 using the second derivative test. First of all, the domain of this function is all real number because it is a polygon function. And the first derivative is 5 times minus 3 is minus 15, x to the power 4, 3 times 5 is 15, x to the power 2, and the second, let the first derivative be 0 to find the critical point, and then minus 15x to the power 4 plus 50x squared is equal to 0. And now take out the common term, which is minus 50x squared. It remain x squared minus 1 is equal to 0. From this one we get that x is 0, and from x squared minus 1 we get that x is plus or minus 1. That means we have 3 critical points. And now take the second derivative. F double prime of x is equal 4 times 15 is 60 x to the power 3 and 2 times 15 is 30x, and now replace x equal 1 at the f double prime of x. It become f double prime of 1 minus 16 times 1 cube plus 30 times 1 is equal minus 30. That means it is negative. Because it is negative, that means that so f has a local maximum at x equal to 1, because the value of the second derivative is negative. And when x is minus 1, replacing at the second derivative, the second derivative f double prime of minus 1 is minus 16 minus 1 cube plus 30 times minus 1 is become 30 is bigger than 0. That means it is, so the function f of x has a local minimum at x equal minus 1. And when x is equal to 0, then f double prime of 0 is equal minus 60 times 0 cube plus 30 times 0 is equal to 0. Then the test is false, and try the first derivative test. But almost this x equal to 0 is inflection point. Find the local extrema for the fx is equal x to the power 5 minus 0.015 x cubed using second derivative test. The domain is all real number. Find the first derivative. F prime of x is equal 5x to the power 4 minus 0.045 x to the power 2. And now let the first derivative equal to 0. So 5x to the power 4 minus 0.045 x squared is equal to 0. Take out the commented term, which is 5x cubed. It remain here x squared minus 0.09 is equal to 0. From 5x squared we get that the x is 0, and from x squared minus 0.09 we get that x is plus or minus 0.3. And now they are the critical point. And now find the second derivative. F double prime of x is equal 20x cubed minus 0.094. And now take the first critical point, which is 0.3, and replace it at the second derivative to find the value of it. The second derivative of 0.3 is equal to 20 times 0.3 cube minus 0.09 times 0.3 is become 0.530, bigger than 0. That means it is positive. So x is equal to 0.3 is a local minimum. When x is equal minus 0.3, so f double prime of x of minus 0.3 is equal 20 times minus 0.3 cube plus 0.09 times minus 0.3, which equal minus. It is less than 0. That means it is local maximum. When x is equal to 0, then f double prime of 0 is 0. Then the test is false. Try with the first test, first derivative test, and almost this point is an inflection point. Question: which of the following statement is false for the function f of x? Be careful, this is the function of f of x. This is f of x. And now let us think about the first one. F of x is decreasing on the interval 1, 3. F of x has two local extrema. One of them is local maximum and the second one is the local minimum, and the function of f of x is increasing or decreasing at the interval 1, 3. That means this is a correct statement. F prime x is decreasing on interval minus infinity to the 2. First of all, to know where the f prime of x is decreasing or increasing, we must searching for the value of the second derivative. The second derivative, it must be negative to make the interval be decreasing for the function f prime of x. And the second derivative is negative when the fx is convex. As you can see here, the function is convexing at this part. That means from minus infinity to the 2. From the minus infinity to the 2. That means the second one, B, is correct. And now f double prime of x bigger than 0 on interval minus infinity 2. That is not correct, because at this interval from minus infinity to the 2, the function f of x is convex, so the second derivative must be negative, not positive. That means it is not true. As you can see here, this is the graph of the function. This is the graph of the second derivative. So it is negative, not positive. So it is not correct. And the point O to 0 is inflection point, because supplies the function from the convexing to the concaves. That means C is false. Question: which of the following statement is not true? To answer this question, take attention or notes from the table. I will give it to you, this one. It says if f prime is increasing on the interval I, then f of x concave on I. Let us see. This is the function of f prime of x. If it is increasing here, that means when the f prime of x is increasing here, that means the second derivative is positive. Because the second derivative is positive, that means the function f of x is concave. That is the true statement. And the second one, f prime of x is bigger than 0 on the interval I, then fx is convex on I. We say if the first derivative is positive, so the interval be convex. The interval be convex if the second derivative must be negative, not the first one. So it is not true. It is not true. That means B is a correct answer. To complete the explaining, f double prime of x is less than 0. That means f double prime is negative in interval I, then fx is convex. So as you can see, the second derivative is negative and the first function or the function is convex. That means it is true. If f prime of x, that means the first derivative, is decreasing on the interval I, then fx is convex. Decreasing, convex, it is true. That means b is not true. Use the graph of f prime of x below, in which open interval the graph of the f prime of x is decreasing. This is the function of f prime. Decreasing is, we have, as you can see, we have two local extrema. One of them is maximum and the second one is minimum. When we draw the vertical line like this, that means this function f prime of x is increasing from minus infinity to the minus 1 and decreasing from minus 1 to 1 and increasing from 1 to the positive infinity. So the f prime is decreasing on interval minus 1, 1. That means B is a correct answer. Use the graph of the function f prime of x below, in which open interval the graph of the f prime of x is concave. To find the concave of f prime of x, concave, this is the inflection point. Draw a vertical line, supply the graph of the function of f prime of x into two parts. At the left it has an convex and at the right is concave. That means the f prime of x is convex on interval from 0 to the positive infinity, which means D is a correct answer. Use the graph of the f prime of x below, in which open interval the graph of the function f of x is convex. First of all, if you remember the table which I give it to you, the f of x is convex when the second derivative is negative and the first derivative is decreasing. So we must search for the decreasing interval for the f prime of x. As you can see, it has two local extrema. One of them is maximum and the other one is minimum. When we draw the vertical line, it supplies the timeline into three intervals. The first one from minus infinity to the minus 1, which is the function is increasing, and from minus 1 to the 1 the function is decreasing, and from 1 to the positive infinity the function is increasing too. So the decreasing interval is from minus 1 to the 1. So f prime of x is decreasing on interval minus 1, 1. Because it is decreasing, that means the function it has the second derivative is negative on interval minus 1, 1. Because the second derivative is negative, so fx is convex on interval minus 1, 1. If we draw the graph of the function is like this, as you can see, it is convex on minus 1, 1. That means B is a correct answer. Use the graph of the f prime x below. X has the inflection points. First of all, to fx must have an inflection point. There must be the second derivative must be 0 or not exist. Because the second derivative is not 0 not or not exist, so the first derivative must have a maximum or the minimum point. So as you can see here, this function, the function of f prime of x, has 2 points, two extrema, local extrema. One of them is maximum and the second one is minimum. And as you can see, f prime has the local maximum at x equal to -1 and local minimum at x equal to 1. So f double prime at these 2 points are, or it is 0. So, and change the sign from positive to the negative and opposite. So the fx has 2 inflection points, one of them at x equal -1 and the second one at x equal 1. That means C is a correct answer. Here we came of the end of this lesson. Thank you for watching, and please do not forget that there is a link for the exercise at the description below, and do not forget to subscribe to get every new video, and write your comment and push the like button. Thank you for that, and goodbye.